What is a computer system? A computer system refers to a combination of hardware and software components that work together to perform tasks and process information. It consists of several key elements, including hardware. This includes the physical components of the computer system, such as the central processing unit, CPU, memory, storage devices, motherboard, input devices, for example, keyboard and mouse, output devices, for example, monitor, printer, and connectivity peripherals, for example, network cards, USB ports. These hardware components provide the necessary resources for the computer system to function. Software. Software refers to the programs and instructions that tell the computer system what tasks to perform. It includes the operating system, that is Windows, Mac operating system, Linux, that manages computer resources and provides a user interface, as well as application software, that is word processors, web browsers, video editing tools that enable users to perform specific tasks. Data. Data is the information that the computer system processes and manipulates. It can be in the form of text, images, videos, documents, or any other digital content. Data can be stored in various storage devices such as hard disk drives, solid-state drives, optical disks, or cloud-based storage. Networks. Computer systems can be connected to form networks, allowing them to communicate and share resources. Local area networks, LANs, connect computers within a limited area, such as a home or office, while wide area networks, WANs, connect computers over larger geographic areas. Networks enable data sharing, collaboration, and access to remote resources. Operating system. The operating system, OS, is a crucial component of a computer system. It manages hardware resources, provides a platform for software applications to run, and facilitates user interaction. The operating system controls tasks such as memory management, file management, device drivers, and security. User interface. The user interface, UI, allows users to interact with the computer system. It can be graphical, such as graphical user interface, where users interact with icons, menus, and windows, or it can be text-based, where users interact through command line interfaces. Together, these components form a computer system that enables various tasks ranging from basic operations like word processing and web browsing to complex tasks like graphic design, video editing, data analysis, and software development. Computer systems are used in numerous fields, including education, business, entertainment, research, and communication, and have become an integral part of our daily lives. Let us now understand the parts of the computer system. Central Processing Unit, CPU. The CPU, or Central Processing Unit, is like the brain of a computer. It has three main parts. Control Unit. The control unit is like the manager of the CPU. It manages and coordinates all the activities happening inside the computer. It tells other parts of the CPU what to do and when to do it. It's responsible for fetching instructions from the computer's memory, decoding those instructions, and sending signals to other parts of the computer to perform the required tasks. Arithmetic Logic Unit, ALU. The arithmetic logic unit does the math and logical operation. It's like a calculator inside the CPU. It can add, subtract, multiply, and divide numbers. It can also compare numbers to see if they are equal, larger, or smaller. The ALU helps the computer perform calculations and make decisions based on those calculations. Registers. Registers are small and super-fast memory locations inside the CPU. They store data and instructions that the CPU needs to work with immediately. Think of them as tiny storage spaces where the CPU can keep important information it needs at that very moment. Registers help speed up the processing because the CPU doesn't have to wait for data to come from other parts of the computer. So, the CPU has the control unit, which manages everything, the arithmetic logic unit, ALU, which does calculations and comparisons, and registers, which store important data for quick access. Together, these three parts of the CPU work as a team to perform tasks, make decisions, and execute instructions that make computers do what we want them to do. Without the CPU, a computer wouldn't be able to think, process information, or carry out any tasks. This brings us to the next important part of computer system, that is, the memory. Memory. Memory in a computer refers to the storage space used to store data and instructions that the computer needs to access quickly. It allows the computer to temporarily hold information that it is actively using. There are different types of memory in a computer system. Here are the main types. Random access memory, RAM. RAM is the primary memory of a computer. It is volatile, meaning it loses its stored data when the computer is powered off. RAM stores data and instructions that the CPU needs to access quickly during its operations. When you open a program or file, it gets loaded into RAM, allowing the CPU to quickly retrieve and process the information. RAM has a faster access time compared to other types of storage, but its capacity is typically smaller. Read-only memory, ROM. ROM is a non-volatile memory that stores permanent instructions and data. It contains information that is written during manufacturing and cannot be modified or erased by normal computer operations. ROM stores firmware and BIOS, basic input or output system, instructions, which are essential for the computer to start up and perform basic functions. Cache memory. Cache memory is a small, fast memory located inside the CPU or in close proximity to it. It acts as a buffer between the CPU and main memory, RAM. Cache memory stores frequently used data and instructions, allowing the CPU to access them quickly. It helps reduce the time it takes for the CPU to retrieve information from the slower main memory, improving overall system performance. Virtual memory. Virtual memory is combination of the computer's RAM and hard disk space. It allows the computer to use a portion of the hard disk as an extension of the physical memory when RAM becomes full. The operating system manages virtual memory, swapping data between RAM and the hard disk as needed. This enables the computer to run more programs simultaneously, even if the physical RAM capacity is limited. These are the main types of memory in a computer system. Each type serves a specific purpose and plays a crucial role in the overall functioning of the computer. RAM provides fast and temporary storage for data actively used by the CPU. ROM stores permanent instructions and firmware. Cache memory improves CPU performance by storing frequently accessed data, and virtual memory expands the effective memory capacity of the computer. Roles and functions of RAM and ROM. RAM, random access memory, and ROM, read-only memory, are two different types of computer memory with distinct roles and functions. Here is an overview of the roles and functions of RAM and ROM. Roles and functions of RAM. Primary memory. RAM acts as the primary memory where data and instructions are temporarily stored during program execution. For example, when you open a web browser, the browser program and the web page you visit are loaded into RAM to allow the processor to access them quickly. Volatility. RAM is a volatile memory. If you turn off your computer, all the data stored in RAM is lost. For example, if you are working on a document and you haven't saved it, the unsaved changes will be lost if the computer loses power. Active data storage. RAM stores actively used data and variables. For instance, when you play a video game, the game's graphics, audio, and player's data are loaded into RAM to facilitate real-time gameplay and smooth performance. Cache. RAM serves as a cache memory. For example, when you open a frequently used program like a web browser, the browser's executable code and resources may be stored in the cache portion of RAM, allowing for faster access and quicker program launch times. Virtual memory. RAM plays a role in virtual memory management. If you have multiple programs running simultaneously and there is insufficient physical RAM, the operating system uses a portion of the hard drive as virtual memory. This enables swapping data between RAM and the hard drive to accommodate the active parts of different programs. Roles and functions of ROM. Non-volatile memory. ROM is a non-volatile memory, meaning it retains its contents even when power is turned off. An example of ROM is the firmware embedded in a gaming console such as the PlayStation or Xbox. The firmware remains intact even after you power off the console. Firmware storage. ROM stores firmware which provides low-level control and initialization routines. For instance, the BIOS basic input or output system in a computer is stored in ROM. The BIOS initializes hardware components during startup and allows the operating system to load. Booting process. During the booting process of a computer, the initial instructions required for the operating system to start are stored in ROM. For example, when you turn on your computer, the BIOS stored in ROM performs a power on self-test post to check hardware functionality and then proceeds to load the operating systems. System configuration. ROM may store system configuration settings. A common example is the CMOS complementary metal oxide semiconductor in a computer. The CMOS, typically powered by a small battery, stores settings like the date and time, boot order, and hardware configuration. Firmware updates. Some types of ROM, like flash memory, can be updated with new firmware. For example, when you update the firmware of a smartphone or a digital camera, you are replacing the existing firmware stored in ROM with a new version that introduces new features or fixes bugs. These examples illustrate how RAM and ROM have different roles and functions in a computer system, serving critical purposes in data storage, program execution, hardware initialization, and system configuration. Motherboard. The motherboard is a vital component in a computer system that serves as a central hub connecting various hardware components. It provides the necessary electrical connections and interfaces for these components to communicate with each other. Here is a brief overview of the motherboard's role and components. Role of a motherboard. The motherboard acts as a platform for all other hardware components to interact and work together. It houses the CPU, RAM, storage devices, expansion slots, and various connectors. The components of the motherboard are CPU socket. The CPU socket is a specific area on the motherboard designed to hold and connect the processor. The CPU is considered the brain of the computer, responsible for executing instructions and performing calculations. RAM slots. The motherboard contains slots for installing RAM modules. These slots allow the RAM modules to connect to the motherboard, providing temporary storage for data and instructions that the CPU needs to access quickly. Expansion slots. The motherboard features expansion slots that allow additional hardware components to be added to the system. Examples of expansion cards include graphics cards, sound cards, and network cards. These cards are inserted into the slots and connected to the motherboard to enhance system functionality. Storage interfaces. The motherboard provides connectors for various storage devices such as hard drives, solid-state drives, and optical drives. These interfaces, such as SATA, serial ATA, or M.2 slots, allow for data transfer between the storage devices and the rest of the system. Power connectors. The motherboard has power connectors that receive power from the power supply unit PSU and distribute it to the various components on the motherboard. These connectors ensure proper power supply to the CPU, RAM, expansion slots, and other peripherals. Input-output ports. The motherboard features various input-output ports to connect external devices. These ports include USB ports, audio jacks, Ethernet ports, video ports such as HDMI or DisplayPort, and more. They enable communication between the computer system and external peripherals. BIOS or UEFI. The motherboard contains a BIOS, Basic Input-Output System, or UEFI, Unified Extensible Firmware Interface, which is a firmware that provides low-level instructions for the computer to boot up and initialize hardware components. It also allows users to configure systems